one of the last concepts you learned in grade 10 math last year is trigonometry. So you looked at two types of problems. You either looked at solving right angle triangles, or you looked at solving acute triangles, which we'll see in a couple of minutes. In terms of solving right angle triangles, there are two things that you could use. Either the Pythagorean theorem. So we looked at when you have a right angle triangle, you know that a squared plus b squared equals c squared, and c was the longer side and a and b were the two shorter sides. Or you looked at SOHCAHTOA, which was just an acronym for the ratios that you look at for sine, cosine, and tangent. Remember that these are ratios, so you are looking at a particular angle in a right angle triangle, and that angle is one of the two smaller angles, not the 90-degree angle. And you look at the ratio between the different sides in this triangle. So either the ratio between the opposite and hypotenuse sides, which would give you the sine ratio, or the ratio of the adjacent and hypotenuse sides, that would give you the cosine ratio, or the ratio between the opposite and adjacent sides, so opposite and adjacent, which would give you the tangent ratio. So what that represents are the ratios between two sides. That's why we call them the sine, cosine, and tangent ratios. So that's what we looked at for solving right angle triangles. Then you also looked at solving acute triangles. When you were solving acute triangles, we needed some new laws or some new formulas to use to help us solve acute triangles. So acute triangles are triangles that do not have a 90-degree angle in them. And so we looked at the sine law and the cosine law to help us solve triangles that do not have a 90-degree angle. And so here's a sine law that's given. Sine of the angle over the side length that's across from it is equal to sine of the other angle over the side that's across from it, etc., etc. And so this is one way of writing it. The other way is to flip the numerator and denominator that we have right now. So you would have the side length at the top and the sine of the angle at the bottom. And so there was two types of triangles that you would actually use the sine law for. And those two triangles depended on the information that you were given. So you were either given the measures of any two angles and one side. So here's an example here. We're given angle B and angle C, and we have side A. Now, remember that whenever you are using the sine law, you need to have one complete ratio. So you need to have an angle in its opposite side. So it needs a complete pair in order for you to actually use the sine law. So if you notice in this triangle, you'll notice that we don't actually have a complete pair. We have angle B, angle C, and little a. However, it's very easy to solve for angle A. That's how you would get the complete pair. So it doesn't matter which two angles you're given and which side you're given, as long as you have all that information, you would be able to get a complete pair in order to use the sine law. The other triangle that you would have is if you had the measures of two sides and an angle opposite one of these sides. And the reason why you need an angle opposite one of those sides is so that you have one complete pair. Okay? So here you can see we have angle C, little b, and little c. And because you have little c and angle C, we have one complete pair, and that means you can use the sine law. Okay, cosine law is the other law that you learned last year that you would use to solve acute triangles. Again, for cosine law, you would use it when you're not given a 90-degree angle. And there's two types of triangles that you would use a cosine law for. The first one is if you're given the measures of two sides and the contained angle. So contained angle means the angle that's made by those two sides. So it's contained between those two side lengths. So we're given it little b and we're given little c, and we are solving, and we have angle A as well. And so what this means is, because we have a side, an angle, and another side, we can use the cosine law to try to solve it. Okay? We cannot use the sine law, and that's because there's no way for us to get a complete pair. And so instead we have to use the cosine law to help start us off, and then maybe we can go back to the sine law to help us finish it off. Okay, the other triangle that you would have in order to use the cosine law, where you would have to use a cosine law, is if you're given the measures of all three sides. So if you're given little a, little b, and little c, then you would have to use a cosine law to get you started on solving the triangle. And then again, once you get one complete pair, then you can go back to using the sine law. So we're going to look at a couple of examples. The first example we have asks us to solve the following triangles. Actually, it's the same example, but there's two parts to it. In the first triangle, you'll notice that you're given a right angle triangle, and so what we're going to do is try to solve this. And remember, when you are given a right angle triangle, remember Pythagorean theorem or the SOHCAHTOA. So those are the two concepts that we're going to use. So Pythagorean theorem and SOHCAHTOA. And so I'm going to list the information that I'm given, and the information that I need to solve for. So I'm given angle A is 36 degrees. I'm given that angle C is 90 degrees. And I'm given that little b is 12 meters. Remember the way we label the side lengths? It's the lowercase version of whatever is the angle across from it. So if this is angle A, this would be side little a. If this is angle C, this would be side little c, and that would be side little b. So the information I still need to find is the rest of the triangle. Okay, so solve means to find all missing angles and sides, and so I'm missing angle B, I'm missing little a, and I'm missing little c. So those are the piece of information that I do need to solve for. So what's the easiest piece of information to solve for? Well, in this case, the easiest thing to solve for is angle B. And so if I look at angle B, once you have two angles in a triangle, you can use the sum of the angles in a triangle theorem, where you would subtract the other two angles from 180 degrees. Since you know all the angles in a triangle have to add up to 180 degrees. So I'm going to subtract both of the angles that I know. And I get angle B is equal to 54 degrees. Okay, so one of the angles are down. We know that angle B is equal to 54 degrees. So that was one of the pieces of information that I needed to solve for. Okay, the next piece of information that I need to solve for is either little a or little c. Doesn't matter which one you try to solve for first. So let's solve for little a. And so what I'm going to try to do is use the original information that I have as much as I possibly can. And I'm going to try to label the sides according to the original angles, if I'm given any, or the original information that I have. So here I'm given angle A is 36 degrees, so I'm going to use this as my angle of focus. And I'm going to label the rest of the triangles, the sides of the triangles, based on that angle of focus. So that means that this side here would be opposite. The side next to it would be adjacent, and the longest side in the triangle would be the hypotenuse. Now, if I'm trying to solve for little a, I'm going to use this angle. I'm solving for the opposite side, and I'm given the adjacent side. So which ratio combines an angle, its opposite side, and its adjacent side? Well, that's the tangent ratio. And I know that tan theta is equal to opposite over adjacent. And so I'm going to plug in the information that I know. I know the angle is 36 degrees. I know the opposite side is A, which is what I'm solving for. And I know the adjacent side is 12. And I can solve for A. And the way I'm going to solve for A is by adding the denominator of 1 underneath the tan of 36 degrees. And then I can cross multiply to solve for A. So 1 times A is A. And then this way I get 12 tan of 36 degrees. Okay, and that part there I can do on my calculator. So I have my calculator ready here. And I get about 8.7 meters as my side length, approximately. So A is approximately 8.7 meters. And I'll label that here as well. Okay, and then the last piece of information that I need to solve for is little c. And because this is a right angle triangle, I could use Pythagorean theorem to solve for the hypotenuse. Or instead what I could do is use another trig ratio. So that's what I'm going to do. I'm actually going to use a different trig ratio. So let's solve for little c. And again, I'm going to think about which information I'm given and what ratio will help me solve for little c. So again, go back to your angle of focus. I know the adjacent side. I'm solving for the hypotenuse. So I need a ratio that combines the adjacent side, the hypotenuse, and an angle. And so adjacent and hypotenuse, that's cosine. That's a cosine ratio that combines those three things. That's as adjacent, sort of. Okay, and I'm going to plug in the information that I know. And so I have cos theta equals, the adjacent side is 12, and the hypotenuse is C. Okay, and so I'm going to try to solve for C again. And I forgot to replace the angle. The angle was 36 degrees, so there we go. So cos of 36 degrees equals the adjacent side over the hypotenuse. And again, I'm going to add 1 in the denominator. I'm going to cross multiply, and I'm going to try to isolate C. So when I cross multiply, I get C cos of 36 degrees equals 12. The operation between the C and the cos 36 is multiplication. The opposite of that would be division. So I'm going to divide both sides by cos of 36 degrees. Those two will cancel out, and I get C is approximately equal to, since this is all the numerical part, I can do it on my calculator. And so I have 12 divided by the cos of 36, which is approximately 14.8. And again, this is in meters. Okay, so C is approximately 14.8 meters. So there's all the information that I needed to find. Now, one of the things you want to remember is that a quick way to check to make sure that your work is correct is if you look at the triangle, the longest side of the triangle is the hypotenuse. It's a right angle triangle. And so the longest side should have, the largest angle should be across the largest side. So this, the hypotenuse here was about 14.8 meters. This is about 8.7 meters. This was about 54 degrees. So one way to check to make sure that you did your work correctly is that the largest angle should be across the largest side, and the smallest angle should be across the smallest side. There's the largest angle, that's the largest side that I have between the three. There's the smallest angle, there's the smallest side that I have between the three sides. Okay, so a quick way to check your work is to compare the angles and sides.